Guys, so this is basically the trick. So I set up the we're gonna prove the trick. So I just set up the cards with little boxes, and they each represent the values, and this is specifically the way that she set up her cards, and you'll find out why that's important. But anyways, we have a goal, right? 6 has to be the final result for this trick regardless of what the player picks. So what this means is that no matter what card you pick, no matter how many steps back you move, you're going to have to end up at 6. You have to end up at 6. Why? Because she can't go change the video. It's already been uploaded, so we all know that. So she can't change it. So that means our final answer definitely has to be 6, without a doubt. So we already have like the first clue. 6 has to be our final card. Okay, so now we're going to this one. If we're going counterclockwise, it makes sense that 1 step back gets you to 6, so 2 steps back get you to 6. So can't we say this? So here it's my own trick. I say pick any card, pick any card. I say 4. Okay, good, 4. Now we're gonna move that many steps back. I'm using the exact same word she's using. So 1, 2, 3, 4. This is your card, right? And then she's like, yep, that's your card. So you know, 3 steps back, 1, 2, 3. So basically think of it like this. If I had 1, right? Well, what's 1 step back? 6. 2 steps back is 1, 2, gets you back to 6. 3 steps back, get you back to 6. 4 steps back, get you back to 6. 5, and so on, right? If we had 6 steps back, it would be 6 steps back, so it would be 1, 2, 3, 4, 5, 6, and you end up back at 6. So it doesn't matter if you pick 6, you'll end up back at 6. So we were going in this order, incrementing this way. So if this would be 7, 1, 2, 3, 4, 5, 6, 7. You see the pattern? Okay. So anyways, look at this and look at this. See if you guys find any similarities. And there is. It's the fact that 1, 3, 5 are the same cards that she used for her setup. Alright? So we already figured out half of it, and now I have another conclusion over here, or another statement, I guess, a proposition. Also, since there are 6 cards, well, I spelled that wrong. No, I didn't. Also, since there's 6 cards, isn't going 6 cards back, starting at 6. So that's a mouthful. Get you back to 6. And I said yes. I don't know. Maybe some grammar mistakes. I don't know. I suck at that. I'm more of a math person. So basically, look. Here's 6, right? And that's basically what I proved here. But here's 6. If we move 6 steps back, won't we be back at 6? Yeah. Well, okay. Let's see. 6 steps back from here would be 1, 2, 3, 4, 5, 6. We ended back. Okay. So now what happens? Excuse me. So if this is 6 steps back in this direction, then couldn't we say that this can be 7? Why? Because if we chose the card 6 and we move 6 steps back, we go back to 6. So in a way, if you choose 6, so C stands for choose. If you choose 6, you go back equals 6. So here, 7. Well, what's 7? Well, no, well, let me not say what's 7. What's 7 minus 1? It's 6, right? So here's 7. If I go back 1, then that gets this part, and then the value becomes 6 now. So if I move 6 back, I'm back at 6. It's the same thing. Here, 8. If I move 2 steps back first, 1, 2, then I'm at 6. Now, if I move, if I decide to go from 8 to 9, and then I move, this is 9, not 4. I'm gonna go 9 steps back from 9, right? Then look, what's 3 steps back from 9? So 1, 2, 3. Then if I had to move back 9 steps, I moved 3 steps already. 1, 2, 3. So I have 6 steps. It's the steps left to go. So 6 steps from here. So if I have 6 steps backwards, I'm going to end up at 6 again. which proves again yet that my final card will always be 6 if I'm incrementing by 1. So here if I'm 10, okay, well, let me move 4 steps back from 10. So I'm going to be 10, I'm going to move 4 steps back. So 1, 2, 3, 4. So 10 minus 4 is 6. So I have 6 steps to move forward while I stopped at 6, right? Because if this is 10, right, I moved 1 step, 2 steps, 3 steps, 4 steps. So I'm missing 6 steps to go, right? But if I do 6 steps from 6, I'll end back at 6 because 1, 2, 3, 4, 5, 6. So if you do it like this, if for any number that you pick, you'll always go back to 6. So what we can do also from here is basically you can see that there's a similarity from this one and this one. And by the way, this is not 2. I have no idea where I wrote 2. This was 10. Remember, this was 10. So let's look at this one and this one and see what similarities they have. Well, the 6 is there, the 8 is there, and the 10 is there, right? So if we labeled this S2 and then this is S1, then the intersection of S1 and S2 give us this. And the intersection just means what they have in well, no, in this case we can't really do a union. We can't even do union or intersection because they don't intersect anywhere. But so this is wrong because they don't intersect. They don't have anything in common based on these two. But what we could say is we could pick definite values from S1, this one, and definite values from S2, which would be this, and this, and combine those two together, and then we would come up with this. You see, 1, 3, 5, 1, 3, 5. Here, 6, 8, 10, 6, 8, 10. Okay, and just for fun, I will do my own card trick, and you'll see that it works. This one I'll put 7. This one I will put, what should I put for this one? This one should be 14, and then we'll test these out just to make sure. This one should be 9. This one we can make 16. This one we can make, we still need this one to be 6, and this one we can make 11. Okay, so this one's mine, made by Jefferson. And then I dare you to do the same thing that she asked you to do on hers. If I did something wrong, then I will be sad. Let's see at 9. I just want to just make sure. So if our number was 9, we had to move 9 steps back. 1, 2, 3, 4, 5, 6, 7, 8, 9. So far it's right. 16. So 16 steps back, and this should be the card for any card that you pick here. For any chosen card. Okay? So, so 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, this is good. This is good. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is good. 6, going back 6 is good. So 7, going back 1, and then that's 6, and then going 6 again. This is good. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Good. Oh, good. So they all bring you back to this one, and you can try it. And you can pick any card, and you'll end up back at 6. And I can say, I know that your card will be 6. So that's the end.